Hi all, this is Ollie Rubens from Undo. Very, very pleased to welcome you to this webinar this morning or this afternoon if you are not on the Pacific coast of the USA. We're talking today about the huge importance of resolving all of your test failures and the value you get from going 100% green in your test farm. And I'm very, very pleased to introduce one of our senior sales engineers who has worked with tens and tens of our biggest customers from EDA to database, working in a huge number of environments, a huge number of different test farms, with a view to helping them get to this sort of coveted place of a green test farm. So Stuart Barnes, I'll hand over to you. Very pleased to introduce you.
Okay, thanks, Ollie. Let me just get a demo screen up. So the thing I want to show you today is really just an example of how we can use Undo LiveRecorder technologies within a test farm kind of environment. And the idea there is that we can show how to leverage the ability to record an application and save that recording into a file and then make that file available to developers for debugging at a later date. That basic idea, when you tie it up with a CI system, is really quite powerful. And I just wanted to show you very quickly how you might do that in your own environments. One example I'm going to use here is a Jenkins. It's obviously a fairly popular CI environment. And the example I've got here is really just to show you a typical workflow. So let's go ahead and take a look at this. So I have a single job. We can see it's in Jenkins. If I take a look at the job itself, you can see we've got a number of runs which have either passed or failed over the last period of time. And I guess this is probably pretty familiar to all those who have used Jenkins in the past. If you're using your own sort of homegrown test farm system, or you're using some other commercial system, this may look different, but obviously the underlying workflow is going to be the same in any case. So I'm just going to drop into the Blue Ocean plugin simply because it gives a nicer visual representation of what's going on. So here I am again. I'm in my my master branch, and I'm just going to take a quick look in there and see what that looks like. So we've set up a Blue Ocean workflow really just to represent a typical overnight test run. And if we take a look at the steps on this workflow, we have the initial build step. We have a test. In this case, we're testing on Docker within Docker containers, and those Docker containers can be run obviously anywhere. In this case, we've got them on an AWS instance. And then we have, because this is a demonstration, we already know which tests are going to fail. Obviously, you're not going to know that yourself in the real world. But we have an idea of what tests are going to fail, and we have an opportunity to rerun those tests. And then at that point, we have a triage and a deploy step. So if I go ahead and just rerun these, nothing really exciting to see here, except we're just running through a typical workflow. So at the moment, we're running through each of the tests. Some are passing and some are failing. The failing tests are going to be re-executed, but the failing tests are going to be re-executed with recording switched on. And the beauty of that is it means that not only do you get your normal test artifacts, such as logs and maybe a call dump, but you're also going to get this our LiveRecorder recording. And what that means is that recording will allow you to replay the execution of your process that just happened in the test farm. So a failing test in your test farm, we're able to capture exactly what that test did and capture the reason why it failed. That capturing then is effectively a portable file which you can give to your developers to debug the problem and find the root cause. So if I just take a quick look through, we can see that in this particular case, we've got some failing tests. So we have here one test called cache, that's failed. I think race also, we've got a simple test and that's passed. But we can see, as I mentioned, that those 3 tests that have failed, we've rerun. Now, I just want to say something about rerunning the tests. Obviously, we don't want to record all of the tests all of the time. There's no real advantage in recording passing tests. So LiveRecorder has a mechanism that allows you to choose whether to save the file out or not save the file out, depending on whether the test has passed or failed. So you have an opportunity to manage the LiveRecorder recording files which are generated after each run. It's also worth mentioning that there is an obvious use case, I guess, here, which is when you have tests that fail intermittently, then being able to run those tests over and over with recording switched on. Let's say the failure only happens 1 in every 100 times, then running that test 100 times, hopefully you're going to capture the failure in the recording, and then you've got that failure forever. You've got a recording of the failure, and you can distribute that to your developers for debugging. That's obviously better than the other situation without recording, where if you come across a failure that's very intermittent, your developers are going to have to run that same test over and over and over again until it fails, and then they've got one shot basically at solving the problem. Otherwise, they're going to have to restart the test again and hopefully get the failure to occur again. So once you've been able to capture the failure within a recording, that recording is then available for posterity, effectively. So what does that mean in practice? In this particular example, the artifacts are stored in a separate area, and we can see that for those 3 failing tests, we have 3 what we call undo recording files, and we can either download those into onto disk and open them using our reversible debugger, or as in this case, we can actually open them within the web session itself. So we have happens to be an Emacs based debug session, and this basically loads up the recording that we made of the failing test and presents a debug session to the developer to step through. The beauty of this is that we can step forwards through the application. It's probably worth me just having a bit of an orientation of what you're seeing on the screen here. We've got in the top left, we have the command window. Below that, we have the source code window, and to the right, we have a disassembly of that source code. In the bottom panels, we have, on the left-hand side, we have the stack frames, and on the right-hand side, a set of breakpoints. And the one thing I didn't mention, in the top left, we have a list of all the local variables. So what the reversible debugger allows you to do is step through the application as you would a normal debugger. We can look at the internal variables at any point, but because we have the entire history here, we can also step backwards and essentially do the same thing. We can look at internal application state at any point, and we can get a pretty good idea of what is happening at any given moment. So rather than go through to the full root cause of this particular problem, I'll stop there, and hopefully that's given you an idea of what a typical workflow would look like, and really just open the floor up to any questions that you might have, anything that might be pertinent to your own environment and how you think we'll be able to perhaps use LiveRecorder to leverage sort of that extra insight into what's going on in your applications.
Just take a look.
in terms of the roadmap?
Okay, so no questions right now. If you want to ask a question, you can ask it within the webinar chat or question panel. But while we're waiting for questions, I'll just say a few things about the way in which this was implemented. As I mentioned, this is using the Blue Ocean plugin to Jenkins. But the key thing here is that we're able to add some logic to that test workflow. So from the build to the initial tests, which are all non-recorded, to identifying failed tests and then passing them on to a sort of second testing stage where we enable recording. That logic is built into this test system right now. And it gives us an opportunity to really leverage a number of different aspects of our technology. The one I've mentioned here of being able to generate a recording of failed tests is just one aspect. We're also able to introduce thread fuzzing into the test pipeline. That's particularly useful if you have non-deterministic style test failures, ones that are probably potentially due to thread fuzzing, thread switching issues, race conditions, deadlocks, those kinds of things. So our LiveRecord recording capability not only records the process history, but also allows you to perhaps cajole some of these more difficult race condition type bugs to appear. We also have several customers who have set up their test farm system in a way that failed tests are passed to a separate partition of hardware, which are dedicated to running these same tests over and over. The idea being there is that we would be able to ensure that we have some physical resource available to do the recordings. So there's lots of different ways to sort of dice the problem, but the important thing is that we see that there are flaky tests or inconsistent tests, and we're able to make a recording of those tests. Again, a nice thing about this is that situations where perhaps the tests themselves are not failing necessarily because of a problem with the source code or the application, but maybe because of a problem in the environment, in the test environment. And again, being able to get a recording of that often inconsistent response to tests allows us to really deep dive into the test failure and make a definite judgment as to whether the failure was due to a fault in the application or a fault in the test environment. And then a third thing that's really useful with being able to make a recording is that if you are trying to debug the recording, not on the test system debug the failed test, not on the test system directly, but on your own local machine, then it's often quite difficult to reproduce the test environment locally and also make that test fail again locally. So by having a recording, you short circuit all those problems, because once you have a recording, you can take that recording, take it to any machine that has our reversible debugger on, and you'll be able to replay the failure exactly as it happened on the test machine. So there are a lot of positive aspects to generating recordings and using our reversible debugger within a CI system.
So a question that's just come through is developer just wanting to understand how in this environment, how they're affected. Obviously, you've spoken a lot about how the recordings are generated, but does the developer have everything they need in this recording to debug the problem?
Yeah, so one of the advantages of the recording is that it records everything that your application touches. So any memory location, any file I/O that occurs, all of that is bundled into the recording. So when you come to do the replay of that recording, any data, anything that happened, any external stimulus to the application is already caught in the recording. So it's pretty comprehensive. And means that you don't have to rely on recreating the exact circumstances that that cause the test to fail on the live system.
And then looks like the final question we've got. What about symbolic information? Is that captured in these recordings?
Yeah, so the symbol information, so let me take a step back. We can record any application, whether it's been stripped of symbols or not. Obviously, when you come back to do an interactive debug session, then you really need the symbols to be present, simply so you can set breakpoints, or you can see a little bit of what function you're in. You get something meaningful in your stack trace. For that to happen, then somehow you've got to attach those symbols back into the debugger, and we we use a standard GDB approach to doing that. So providing your symbols are available, you can record a stripped, optimized version of your application, and then you can replay that recording once you've reattached the symbols. And also, if you have the source code handy, then that's going to make that debug session much easier.
Fantastic. Thank you very much, Stuart. So I think that's all we've got time for. Hopefully you found this informative as to both the value of going green and also how you might go about that using Undo's technology. If you want to learn more, then please do visit our website, undo.io, for more information, and you can reach out to us through there. Thank you. Goodbye.